In just 7 minutes, let's learn how to natively create and utilize a session key within Particle's Smart Wallet as a Service. Session keys are among one of the most exciting use cases for ERC 437 account abstraction. Essentially, through utilizing session keys, you can facilitate completely pop-up-less transactions. So while you might be submitting state-changing actions on-chain, the user doesn't need to actually sign anything because the session key is doing it for them. Think about this in the context of a game, where traditionally you'd have to sign every transaction that corresponded with an in-game action. Instead, by using a session key, you can define conditions in which transactions are automatically signed on behalf of the user, removing the need for pop-ups within most on-chain actions in the game, thus significantly increasing the overall user experience within that game and ultimately making it feel a lot more Web2 adjacent. You can imagine the power of matching this with social logins, onboarding a user through their Google account, and then having them use a Web3 application with no signatures, with no pop-ups. This is the future of Web3 applications, something that feels very Web2-like while still retaining the benefits of Web3. So this is exactly why last week we released native support for the creation and utilization of session keys within our account abstraction SDK. Thus, in just 7 minutes, we're going to be creating a demo application that uses Biconomy's V2 smart account within our Smart Wallet as a Service alongside our account abstraction SDK to create a session key and use it to mint a sample token. So let's jump right into it. So managing session keys natively within our account abstraction SDK is quite simple. This is functionality that we actually just recently introduced basically over the past week or so that essentially allows you to create and use session keys directly with our Smart Wallet as a Service, thus creating the possibility for a very simple onboarding flow and even more powerful interaction flow with the implementation of these session keys. So as you can see, I have my application structure here. If you're familiar with these videos or any of our usual repositories, and you might recognize the structure, it's pretty standard. Basically, we're importing all of our libraries, we're configuring Particle Network, then we're configuring Smart Account from our account abstraction SDK. In this case, we're using Biconomy V2. We're setting up a custom provider. Then we're fetching the balance of the smart account and handling social login and logout. So what we want to do here is basically add two extra functions, both corresponding to their own button in the front end. The first will be create session key. This will allow us to basically format and ultimately send a transaction that will initiate a session key, which we'll then use for the second function, which is execute user operation. And there we'll mint a token, specifically an 1155 token, all without having any pop-ups because of the utilization of the session key. So let's start with that first function that I mentioned, which is create session key. Let's call this create session. Before doing anything, just for the sake of the application, I want to quickly throw a notification.info and basically just let the user know in this case that we are creating the session key. One thing to note with this process is that it can take a moment. It's not instantaneous. So in my case, I'm going to let the user know that it's processing so they don't think that something is wrong. Okay, so now for the function itself, we'll need to start by creating a random key pair, basically just a fresh account that we can use within the session key. Let's name this signer and call wallet.createRandom. Specifically, I'm importing wallet from Ethers, which is available within the new version of Ethers. I also need to retrieve the address of the smart account, which I can do in a variable called address with await smartaccount.getAddress. Okay, so now with the set, we can create the session key itself. Let's call this session key and just simply call await smartaccount.createSessions. And then in here, I'll need to define a few configurations. Let's start with valid until. I'm gonna set that to 0, but basically this is the expiration or how long the session key will last. By setting it to 0, I'm configuring the session key to last forever. Additionally, I can do valid after, which will basically put this on a timer. Similar to valid until, I'm going to set this as 0. We can also define our session validation module, which will essentially validate a given user operation that we're trying to pass through a session key. This should be a specific contract. In my case, it's this address right here. Let's also define session key data in ABI. And in here, we can create an ABI-like structure for, again, the parameters and configuration of the session key. Within this array, we can do address, and uint 256. Then we can throw in the address of the account that we generated in the signer variable alongside the address of our smart account. Then we can go and pass in 1, and there we go. That'll basically create our session key, although we'll need to sign and validate this with await smartaccount.sendTransaction. Then as the transaction, we can pass in session key.transactions. You can also go ahead and set a state here with set session. I'll pass in session key. This is just a very simple state here with session and set session. Of course, we'll do the same thing for wallet with set wallet. You can pass in signer. Okay, so now with that set, let's move on to sending a sample user operation, in this case, a mint of a specific 1155 token. So let's call this execute user op. And in here, we can once again go ahead and retrieve our smart account address. Then we can go and define a variable called mint interface, which will be new interface, also imported from Ethers. And in here, basically need the specific method that we're going to be calling on the contract in a moment. This will be function mint2, which of course will take address and a uint 256 and another uint 256, and that'll be public. Then below this, we can define encoded data, which will be mint interface.encode function data. Then we can pass in mint 2, and then address, and 1, and then 1. Now that we have our data field ready, we can move on to creating the actual transaction object itself in TX. And this will be quite simple. For the to field, we can set that to the token contract. Then for value, we'll be doing 0, of course. And for data, we can pass in what we just created, which is encode data. And then now with the set, we'll basically just need to construct the user operation and then push it to the network. Let's start by defining user op and doing await smart account.build user operation and pass in tx. Although in a moment, we'll be using a method called send signed user operation, which requires a user operation to already be signed before it sends it to the network. So we'll need to quickly sign this user operation before sending it in a moment. So we can define signature and do await wallet.sign message. And then of course within here, we can pass in get bytes and then user op hash. And now finally in a variable called hash, we can do await smart account.send signed user operation, which to begin will take user op as well as the signature. Then we can also define the target session, which in this case will be session.sessions in the first item. And additionally, we can pass in sessions as session.sessions. And that's it. So before we close it off, let's quickly throw a notification.success and pass in message as hash. So we're now creating a session key with create session. Then we're testing it with execute user op. And of course, we're mapping both these buttons to the front end with our JSX right here. So we can go ahead and run this and see if it works. And perfect. And go ahead and give this a try by signing in with Google. I'll go ahead and select this account right here. And then here we go. I'm now signed in. And as you can see, I have 0.11 Matic within this account. So I'll go ahead and start by clicking create session key. And it says creating session key right here. Now, of course, we have the signature. So I'll go ahead and click on confirm. And there we go. The session key has been created. And we have the execute user operation button right here. So let's go ahead and give it a try. You can go ahead and click it here. And there we go. No pop-ups. I just clicked the button right there. So let's go ahead and copy this and check it out on the Explorer. You can see about 30 seconds ago, the full transaction was completed and we minted this token to my address right here. The possibilities when it comes to what you can unlock in terms of truly accessible and powerful user experience by utilizing session keys is limitless. So we're really excited to be natively supporting the management of session keys within our account abstraction SDK, of course working best natively with our smart wallet as a service. On that note, if you'd like to learn more about our smart wallet as a service, then I'll have a video diving into that linked below. Otherwise, if you'd like to give our web demo a try, or if you'd like to try the demo that we created today, you can find both of those links below.